Welcome everyone to the Innovation Flow Podcast, where we talk all things PARC. We talk wastewater technology, pilot projects, research going on in the industry, and I have a very knowledgeable and experienced guest with me today, Professor Tzahi Cath, who's a professor at the Colorado School of Mines. Thanks for being here, Tzahi.
Hey, you're very welcome. Pleasure.
I'm glad you found the time to come talk to us, because I know you got a lot of interesting things to talk about and a lot of questions I've been wanting to ask. And so I know you're involved in the DPR trailer, and so I think we're going to talk about that. But before we do that, can you give us a little background of yourself and your history and what you're doing currently?
So yeah, I'm, as you said, professor at Colorado School of Mines. I've been there for 18 years now. Before that, I got my PhD at the University of Nevada in Reno. And I'm doing research and teaching in the environmental engineering department at the School of Mines. And I'm focusing mainly on teaching of unit processes for water and wastewater treatment. So again, both the teaching part and the research part, and it's across the gamut. You know, water, wastewater, desalination, industrial wastewater, everything related to water.
Nice. All right. What do you do? What do you do when you're not teaching or researching or building things? What do you do for hobbies?
I'm still building,
yeah,
but
right.
things from wood, you know. So yeah, my main hobby is carpentry, and I still have 10 fingers, so I'm still okay.
That's good. Yeah, that's good. You got a bandsaw?
You know, this is the one thing that I have everything else against except for bandsaw.
Oh,
but
well, that might be why you have your fingers. Yeah. What kind of stuff do you make?
Shelves. My wife likes books, so I all the time have to build more shelves and cabinets and the doors and things like that. So
cool. You find it. What do you like about it? Why do you what?
Oh, it's relaxing. It reduces the blood pressure.
Yeah.
It's really fun.
Cool. Well, right on. For our icebreaker question, and I sent you this early because I know it takes a little bit of time to think about it, but the icebreaker question is, what's the best advice you've ever received or you've ever given to one of your students?
So, advice that I received, a few of them from smart people. One is when you point at somebody to blame, always remember there are 3 fingers pointing at you. So always remember this.
Yeah, I like that one.
The other one that I sort of used to give advice to students is there are no stupid questions. There are only stupid answers. And just don't be afraid to ask questions. Every question is a legitimate question. And another advice that I got from one of my mentors is we can live without cars, without telephones, without houses. We can't live without water.
Yeah.
And so go for it. Water is important, and I think that's what I took into my professional career.
Yeah. So what's been driving you, huh?
Yeah, that's we need it.
Yeah.
We can't live without it.
Yeah.
And I think that's where eventually drives the direct potable reuse DPR, because there are places that don't have the ocean to take from the ocean or don't have lakes, and one of the options, and it's a relatively cheaper option, is to take wastewater and turn it, or I don't want to say wastewater, I want impaired water or water that's currently not being used as a resource for drinking, but that's doable. We have the technologies, and we just have to make it a viable option and a economically viable option. So,
yeah.
And that's what we are doing in the research.
Cool. Well, let's get into that a little bit and talk about the DPR trailer. So DPR, direct potable reuse, I think you mentioned that.
Yeah.
So tell us a little bit about how this trailer came to be and how the idea was formulated and where it came from.
So overall, direct potable reuse, the idea take reclaimed water from wastewater treatment plant and upgrade them through a series of processes to drinkable quality level. I felt comfortable because that was part of my PhD dissertation. It was a project for NASA. When you go to space, you cannot bring with you all the water, so you have to recycle and reuse. And at the time, it was the reference mission, was to go to Mars, and for sure, 6 months going one way, 6 months another way, and 2 years to work there, you don't have enough water.
Yeah.
And so I think that was fascinating. And then when Colorado Springs Utilities came to me with engineers from Corollo Engineers, and they said, hey, we want to demonstrate to our customers that it's possible and that might be part of the future, we sat together and started running ideas how we will do it. And one of the ideas that came up is like, let's put it on wheels. So when we are done with the project at Colorado Springs Utilities, we'll go to other communities and other utilities, and we'll be able to use the same infrastructure to demonstrate to others that potable reuse is viable. And that's where it started. We got funding from the Colorado Water Conservation Board, from the National Science Foundation, from many companies that contributed technologies, equipment. We finished the design with the help of Corollo, and then COVID came and messed up a little bit the plans. But we had dedicated people, including Mason Manros, which he's now an engineer here at Sasplat Renew, and he was part of the few people that helped the design and building of a trailer like that. And then in the middle of 2021, we deployed it in the field, and since then it's working nonstop.
All right. Well, that design process, you said you had Corollo helping with that. Did they design it and then you built it and it was done, or was there any iterative process to say, well, we need to add this, or we need to change this? Or
That's a great question. So they helped, with the conceptual design. We took the conceptual design and, put it into unit processes design, because we have several technologies inside this trailer. Mm-hmm. And the order of processes stayed relatively similar to what we started with, but slowly we added flexibility to be able to bypass processes or change the order of processes. And then we did the fabrication and the integration in building the control system, which is not simple.
Yeah.
At the end of the day, this is a water treatment plant in a very small footprint, and you have to think about many, hydraulic limitation and control limitation and electricity limitation. We just recently, just before we came back here with the trailer, we added another 100 amps of power into the trailer because it was not enough at the beginning.
Yeah.
We slowly added more technologies to the trailer to test technologies. We started working with other companies that provide technology to use it as a test bed for them to test new technologies. So you start with something and you slowly change it, and then you say, I was like, oh, we don't have enough room.
Yeah.
And so maybe we need to design and build a bigger trailer.
Yeah.
But it's the fun of the discoveries that you do when you really do applied engineering.
Yeah. Yeah. So you had students involved in that too, like helping build it?
Yeah. So we have currently we have 5 students working in this trailer, each of them working on different research. This trailer, we call it the National Science Foundation, like this phrase, testbed. This is and the way that I define testbed, it's a platform that people can come from different disciplines and do research together on different components of this platform. Mm-hmm. And it's a beautiful concept because each of the people depends on each other, the research depends on it, so it becomes a little bit complicated to coordinate, who is doing what and how do you make sure that one student doesn't interfere with the experiments of the other student. But we have students looking at studying, investigating the control system, biological treatment, chemical treatment, removal of emerging contaminants, data. So a lot of the research involved data science integration into water and wastewater treatment, which is, I think, fascinating.
Yeah.
And we can talk more about it. But yeah, and we can bring more students to work on that. We have students from CU Boulder working on new UV ultraviolet radiation technologies. So it's also not only people from School of Mines. We're bringing people both from the industry and from other universities to do research there. So it's cool.
That is great. You have the latest and greatest, the latest technology, the vendors who want to try stuff out. You got students chomping at the bit to learn all that, and experts who can guide you through all that. It sounds like a good deal.
Yeah, I wouldn't look for another job in my life.
Well, good. Well, let's dive into the technologies that are in the trailer. You mentioned some of them, but can you take us kind of through? I always get this question because I work at South Platte Renewable Wastewater Plant. And people say, "Well, can you drink it when it comes out the other end?" And it always amazes me, how little people understand what the wastewater plant's for and what. Anyway, I guess my question is, take us through the technologies of how you turn wastewater into drinking water.
So the truth, I drank the first water that came out of the trailer. It was horrible, but it was horrible because we ran it through a brand new garden hose.
Oh.
You know this horrible taste of garden hose?
I grew up in the 80s. I know that taste.
Yeah, same thing. It's like... but I'm still alive, and there are other people that drank this water and they're alive. So when you look at this trailer, we looked at the concept we called multi-barrier approach. So we have 6 to 7 processes in a train that the water goes from one process to another, and every process is another barrier to smaller and smaller contaminants, and some of the processes can remove several of these contaminants or group of contaminants, but we're trying to achieve sort of this log removal of different things, of the microorganisms, of the chemicals, of the particles. And so we start the process with ozonation, which is a strong oxidant that can be used as disinfectant process, but we're using it more for breaking down organic compounds that are more difficult to break down.
Okay.
And we're breaking them down in order to enable the next step, which is biologically active filters, to allow the microorganisms to more easily chew on this organic, because we want to remove this organic from the water. And so we are in this biological active filters, we can remove up to 30% of the organic matter that was coming with the water. After this, we're going through a very tight membrane, a filter, 0.04 micron, so it's smaller than bacteria, it's smaller than Giardia, and it's at the size range of viruses, so most viruses are removed there. And so we get very, very clear water, still maybe with some dissolved constituents that manage to cross this barrier. From there, we go into adsorption processes, activated carbon, or ion exchange resin, or other new adsorbers, specifically, for example, for PFAS, which is an emerging contaminant that we have in water sources. So we're trying to remove these organic matter in this adsorption process. And then the next step, we go through UV, ultraviolet radiation with advanced oxidation. So we are injecting some peroxide or chlorine into this, again, to further break down any organic matter that managed to cross the membrane. And the end process is a chlorination, which just we're adding chlorine to the water, that if this water is becoming drinking water one day, it has residual chlorine to protect people. But in our case, we are adding this chlorine. People on a regular basis, we are not drinking this water. If we are planning to drink this water, we go through very extensive water quality analysis. But when you add chlorine, you can generate some disinfection byproduct, which are also emerging contaminant. And so we are trying to study to make sure, again, through investigations, that we are not generating any harmful disinfection byproducts. In addition, last year we added the reverse osmosis process to the, it's only on a side stream, but the nice thing about this trailer now is that we can side by side at the same time with the same water test two philosophies of potable reuse, one that has a reverse osmosis inside and one that doesn't have. So, for example, in Colorado, inland states, they don't like to use reverse osmosis because you generate concentrated brine that what do you do with it?
Yeah.
If you go to California or Texas or Florida, you can send this brine to the ocean. And so we look at the quality difference between with reverse osmosis and without reverse osmosis. So it opens up more opportunities for research.
Yeah, nice. How long does it all take? If you take a drop of water at the beginning, how long does it take to work through there?
It's a little bit less than 2 hours until the water comes out. The system designed for 7,000 gallons per day,
Okay.
or think about around 5 gallons per minute, and it's within 2 hours the water is coming out drinkable.
Huh. Well, I've drank some of it. We had a tour.
Yep.
And I always say it was surprisingly good, but they told me to quit saying surprisingly because you shouldn't be surprised because of all the technologies it's been through. But you just think when you drink it like that, you don't know, but it was delicious. I loved it.
Yeah, the thing, we have the technologies, and here, and we put them into a trailer. I think the one thing that's missing is how to make this very efficient and affordable.
Yeah.
And that's part of the research. Can we do it for every community, both communities that are affluent enough to have the resources to build things like that, or people that are less fortunate and still need to drink clean water for their health.
Yeah.
So that's what we are doing here.
Nice. What do you think about the social side of it? I mean, you're a scientist, you're a PhD, so the technologies you have dialed in and can do it. But how do people receive it? What do you hear? What's the feedback do you hear from them?
So I think the best exercise was in the first year of operation when we were in Colorado Springs. So Colorado Springs Utilities started this project or program with the intention of doing public outreach. And there were many people, many groups that came to visit. They drank the water, they drank, other beverages that we made out of this water. And they did the exit surveys. They asked the people what they think about it. And more than 99% of the people liked the idea, wanted it to continue, wanted to improve because they understand that, one, it might be part of the future.
Yeah.
And second, we're better off testing it now and improving it now and making it bulletproof now before we are going to use it. So, and there was activity around these groups, with explanation, with going through the trailer, through looking at posters. Mm-hmm. And when people are smart. People eventually, it's like you explain to them how it works, even if they are not expert in the field, they understand that we are putting so many barriers that it will be difficult for things to go wrong.
Yeah.
And for the things that go wrong, we tell them about the interesting research that we do with data, because the data science that we're trying to integrate into these processes is looking at the data. Even a plant like that, we have you have a control room here that the operators see all the time what's happening, see what's the water quality. But that all this data, they look at it when it happens, and if everything is okay, it goes and saved in a server, and nobody looks at it anymore, right? And I tell people that this data that's now sitting in the server has golden diamonds in it, because if I can start compiling this data and look at how water quality changes with time, or how energy is consumed at the plant, I can develop algorithms, people call it today machine learning or artificial intelligence, but whatever it is, I can predict early enough if something goes wrong at the plant, if the water quality changed, if the energy consumption went up, and I can optimize or minimize the energy consumption. I can minimize chemicals consumption, and I can really detect if something bad is happening. And in direct potable reuse, it's more important than in water treatment or in wastewater treatment.
Yeah.
And so, but everything that we develop here, we can eventually implement in water and wastewater treatment plants.
Yeah.
So that's, these are the great things that a platform like that can help you develop.
Yeah, one thing I noticed being out there is the amount of, I guess, sensor. I mean, there's no lab where you're taking samples. A lot of times, wastewater, you put samples in a container and then you take them to the lab and you run them, and then the next day you get results. And out there, it's all real time, and there's sensors. Can you talk a little bit about the sensor technology?
So we were very, very lucky to team up with Hawk, which is actually a Colorado company based in Loveland, and they donated a lot of equipment to put in the trailer to help us with the research, and we still work with them on testing new technologies. And that's great. This trailer is generating 1.8 million data points every day.
Wow.
And we are storing them in our servers, and students are tapping into this data and doing a lot of research, which is cool. Do we have all the and again, you mentioned it, that it takes this 24 hours or whatever to get. We need more of these sensors to be able in real time to say, what happened to the water, and we don't have enough of them. Again, we have the best of the best that exists today, but we need more research to go into developing more advanced sensors that can in real time tell you what happened, because you cannot adjust processes unless you know what's the water quality. So this is another area that we are, at least preaching all the time, even at our campus, to the administrator, hire more people that can develop sensors, because without it, we are in the dark.
Yeah. There's a test, I'm sure you're familiar with it, we run all the time. It's required for our permit, but also process control. I guess what's called BOD. You set it up and then you read it 5 days later and get a result, and it's always like, what are we going to do 5 days later? That water's in Nebraska.
Yeah. So and again, there's no secret here when you look at EPA regulation for drinking water, not for, I ask some students sometimes, how often do you think a water treatment plant analyze their water to know that the water is, below the regulated levels? Yeah, we have some contaminants in the water that we test only 4 times a year. Yeah. Which is, that's by the regulation. Is it okay? Again, we know that in general these contaminants are not in our watershed, and most likely it's not there. But again, I wish that we had a sensor for everything that we want to know that's in the water or not in the water. Yeah. So.
All right. Well, what does the future hold? I think the trailer's been to. You said it started in Springs. I think it had a stint in Aurora, right? Or where else has it been?
So Aurora. So Colorado Springs, Aurora. Here it's South Platte, then in Metro, and then back here. So this coming summer we are going west. Oh. So we just got a nice grant from the Department of Energy to bring it to California, to Silicon Valley. Nice. To test it on more complex water with other technologies of pretreatment, and I think that's exciting. California, more than any other state, probably they need more water, and I think that's a help that Colorado can help. Other states with testing it. We'll be there only 1 year. Other places, from Washington State to others, everybody asks to have a trailer like that. So. There's a lot of pressure on us to build more of these trailer, but I tell people, it's like I'm already lost all my hair, so I don't know if I can build. But if I had to build it, of course we'll build it completely differently with a different complexity, different flexibilities. I don't think that with different technologies. I think that the technologies we have there, they're good. We just have to improve them. We need to optimize the processes that we have there. But it will be exciting. So that's the next place.
Yeah, it's great that Colorado's leading the way on that, both in the technologies and I know they were one of the first to pass DPR regs, statewide.
Yep.
And so it's good that we're leading the way.
Yeah, absolutely. And then they asked me if we'll be able to change the banner outside the trailer to say California. So it's like, probably not.
Yeah,
it will
don't
stay
let them do
Colorado.
that. That's right. Well, good. Well, you got me thinking. I've been thinking this whole time. You talked about NASA transporting water to Mars and to the moon. So I got to ask you, how do they do that? How do they treat water, like on the space shuttle or these things?
So they have some filtration units for, I don't think for potable, and I haven't kept up with what they're doing, but they have batteries that, the byproduct of the battery is water. So while they're generating electricity, they're generating water also. And I think the wastewater is sent back to Earth. But producing water or treating water in what we call life support system, which is, space application. Yeah. This is challenging, and again, it was fun when I did the research on that because you have three main streams. You have humidity condensate. When you have to control the humidity, you are producing condensate from that, and then you have hygiene wastewater, which you don't generate much. You don't take much showers in space.
Oh.
And the last stream is urine. It's like, how do you produce water from urine?
Yeah.
So each of these streams is very challenging, and it's not easy to. But again, I think that when I did this research, to me always was like, okay, how do we take it and apply it on Earth? Because what do you need for spacecraft? When you talk about wastewater treatment, you need something that have very small footprint, that takes very minimal energy because you don't have much energy. You want zero replenishment or supplies that you need to replace filters, because then you'll have to bring these filters from somewhere. Yeah. And you need zero maintenance. The astronauts don't have time to do maintenance.
Yeah.
Don't we need all these four things here too? It's like, if we manage to do the same thing here, then the treatment of water will be much cheaper and will be more affordable.
Yeah.
And so again, it's the nice thing that you learn from different applications of water treatment and different disciplines.
Well, cool. Well, thanks for coming by today and giving us a tour through words of the pilot trailer. It was interesting to hear about how it came about, what's involved in it, and what's produced from it, and where it could go from here. So I appreciate you taking the time and sharing that with us today.
And it's my pleasure. And again, it was really great, this collaboration with the SASPAT Renew. We couldn't ask for a better place and better hosts to share with us the research that we are doing. So thank you from me and from my students and from everybody involved in this project.
We love it too. I love it. You get a little sense of pride when someone, drives by and says, that's the mines trailer. There's people from mines doing research right there, because everyone thinks the wastewater is, I don't want to go there. And you're like, you might. There's some cool stuff going on.
Absolutely.
Cool. All right. Well, thanks, Tzahi. And to the listeners, thank you for listening to Innovation Flow. If you're catching the flow, give us a thumbs up, give us a 5-star review, or like us on YouTube. And thanks for taking the time to listen to the show today. We'll see you next time on Innovation Flow Podcast.